Welcome to the deep dive. Today we're really zeroing in on something specific. We've got this expert-level syllabus for Salesforce Lightning Web Components, LWCs, and we're going to break it down into like 3 clear stages. So if you're aiming to become that LWC expert, our mission here is pretty simple. Give you that clear roadmap, cut through the noise, and hopefully shorten that learning curve.
Yeah, and LWCs, I mean, they really are foundational now, aren't they, for modern Salesforce development? It's how you build those really slick, fast apps.
Right.
And the blueprint we're using today, it comes from Raksha Sanganee. She's a seriously respected solution consultant and architect over in the UK Salesforce community, just known for her incredible depth of knowledge.
Okay, so we're talking real credibility here. I looked her up 14 Salesforce certs, including application architect.
Yeah, and that's not all. 15 times all ranger status on Trailhead.
Wow. Okay. So when someone with that kind of deep expertise, across Apex, JavaScript, LWC itself, lays out a structure, you pay attention.
Precisely, yeah. She essentially handed us the curriculum,
Wow.
for LWC mastery. And she breaks it down really nicely. Beginner, intermediate, and advanced.
Perfect.
So that 3-part framework, that's going to be our guide for this deep dive.
Okay, sounds good. Let's unpack it then, starting with segment 1, the beginner's ascent. Now, it's tempting, right, to just jump straight into writing code, HTML.
Oh, absolutely.
But this syllabus really hammers home the prerequisites. What do you absolutely have to get sorted before you even think about LWC code?
Well, it's the core Salesforce stuff, the foundational architecture. Raksha really stresses understanding the data model, objects, fields, how relationships work. That's non-negotiable.
Why, though? Can't you just learn the coding part?
You could try, but look, you can write like perfect JavaScript, beautiful code, right? But if you don't get why a contact relates to an account through a lookup field, for example, well, your component just isn't going to work properly inside Salesforce. It won't understand its own context.
So it's about knowing the playground before you start building the sandcastle.
Exactly. That's a good way to put it. And it's not just the data model. You also need a solid grasp of security profiles, permission sets, and the automation tools like flows, process builder.
Ah, okay. Why the automation tools?
Well, you don't want to build an LWC that just replicates something Flow can already do easily, right? Or worse, build something that accidentally bypasses the security rules you've set up. It's about understanding the whole platform.
Right, platform first. Okay, so once you've got that foundation, then the beginner phase moves into the actual LWC structure, the HTML, JavaScript, the XML file.
Correct. And the big concept here initially is reactivity, how changes in your data automatically update what the user sees.
And the syllabus mentions using the iTrack decorator for that.
It does. Now, here's a little nuance. In, let's say, modern LWC, for simple data types like strings or numbers, just assigning a value often makes it reactive automatically. You might not strictly need @track all the time anymore.
Okay, wait, so why focus on @track first then if it's kind of becoming less necessary sometimes?
That's a fair question. I think it's because @track is still the clearest way to demonstrate the concept, especially when you start dealing with more complex things like objects or arrays. For those, you often still need @track to make sure changes inside the object trigger the update.
Oh, okay.
So it helps build that fundamental mental model, data changes, UI updates, get that concept down solid with @track, then you can learn the optimizations later.
Gotcha. Master the core idea first, and then there's the practical side.
Yeah.
The thing that often trips up beginners, right? Setting up the whole development environment.
Oh, absolutely vital, yeah. You need Visual Studio Code, that's the editor. Then the Salesforce extension pack gives you all the nice syntax highlighting and stuff. And crucially, the Salesforce CLI, the command line interface.
The command line. Yeah, still essential.
Totally. And Raksha points out a couple of commands you basically live by. SF project, start metadata dir force app, that's how you push your code up.
Right.
And SF org just quickly opens your Salesforce org in the browser.
Those little commands, they seem small, but they save so much clicking around over time, don't they?
Oh, immense amounts, yeah. I remember starting out manually uploading zip files. It was painful. Mastering the CLI early just transforms how efficiently you work.
Okay, so that's the beginner stage. Platform knowledge, basic LWC structure, reactivity concept, and your tool setup. Now, assuming we've got our basic Hello World LWC running, the intermediate stage seems to shift focus. It's about making components talk, right, to each other, and importantly, to the Salesforce database. This takes us to segment 2, the intermediate climb.
Exactly. This is where things get really interactive and powerful. And yeah, component communication is first, and she rightly calls it huge GE because real apps aren't just one component, are they?
No, they're collections.
Right. And there are basically three main ways components talk, depending on how they're related.
Okay, method 1 sounds like the simplest. Parent passing data down to a child component using properties or props.
Yep, that's it. Strictly data flowing downwards. So imagine a parent component, like a list, has a specific record ID. It needs to tell a child component, like a detail view, which record to display.
How does it do that?
The child component declares a property in its JavaScript using the @API decorator, like @API recorded, that makes the property public. Then the parent component, in its HTML template, can bind the value to that child property.
Okay, parent to child via @API. Got it. Method 2 is the opposite flow. Child telling the parent something happened using events.
Exactly. The child needs to shout up, basically. So maybe the child has a button, someone clicks it. The child dispatches what's called a custom event.
Custom event.
Yeah, you give it a name, like contact select, maybe pass some data in the detail property, like the ID of the contact selected. The parent component then listens for that specific event name, contact select, and runs some code when it hears it.
Okay, so it listens, catches the event, but you mentioned a limitation here.
Yeah, this is key. Standard events only bubble up one level. They stop at the direct parent. So if you have like parent-child, grandchild, and the grandchild fires an event, the parent won't hear it directly. The child in the middle has to catch it and then refire it for the parent to get it.
Okay, that sounds like it could get complicated, which leads to a question. If events handle child to parent, why can't I just use events between sibling components? You know, components next to each other on the page. Why do we need this whole pub-sub thing?
Great question. Because they are siblings, there's no direct parent-child path for that event bubble to follow between them. That's where method 3 comes in. Publish subscribe or pub-sub.
The bulletin board analogy.
Exactly. Think of it like a shared message board. One component, say a filter component, can publish a message to a specific channel, like filters updated. Another totally unrelated component, maybe a data table somewhere else on the page, can subscribe to that same filters updated channel.
So they communicate without knowing about each other directly.
Precisely. The message board handles the connection. Very useful for decoupling components.
Okay, mastering those 3 props, events, pub-sub, that seems like a huge step towards building real applications. Now, the other big intermediate piece, getting data. Apex integration.
Right. Connecting your pretty LWC front end to the actual Salesforce database. This is for all your CRU'd operations, create, read, update, delete.
And the main tools here are decorators again, at OR enabled in Apex and at Wire in the LWC.
Those are the workhorses, especially for reading data. You mark your Apex method with @OR enabled, often with cacheable true for read operations.
Hold on, cacheable or true. The syllabus emphasizes that for fetching data. Why is that so critical for performance? Beginners often miss this, right?
They do, and it's vital. If you forget cacheable true on your Apex method that just reads data, the system has to go all the way back to the server every single time that component loads or needs that data, even if nothing changed. But if you set cacheable true, Salesforce is smart. It caches the results on the client side. So if the user comes back to that page or the component re-renders and the underlying data hasn't changed, boom, it loads instantly from the cache. No server trip needed. Huge performance win.
Okay, so cacheable true minimizes those expensive server calls, and then the @wire decorator in the LWC just hooks into that Apex method.
Pretty much. @wire handles calling the Apex method, getting the data back asynchronously, and providing it to your component's property or function. It also nicely handles loading states and potential errors.
So it simplifies things a lot. But you can't use @wire for everything, can you? Like saving data.
Good point. No. @wire is primarily for reading data. For actions like saving, updating, or deleting things that change data, you need to call Apex imperatively. That means writing JavaScript code to explicitly call the Apex method, often when a user clicks a button, for example.
And handling errors becomes really important there, I imagine.
Crucial. An intermediate developer absolutely has to learn how to handle errors gracefully. If your Apex call fails when trying to save a record, your LWC needs to tell the user what went wrong in a friendly way, not just, crash or do nothing.
Right. Makes sense. And since we're talking Apex for data access, we have to mention the query languages.
Yeah.
SOQL and SOSL.
Yep. You need to know which one to use when. SOQL Salesforce Object Query Language, that's your go-to for pulling data from specific objects when you know the relationships. Like, get me all the contacts for this particular account.
Standard SQL-like queries.
Sort of, yeah. But Salesforce specific. Then there's SOSL, Salesforce Object Search Language. That's different. That's for searching for a term across multiple different object types at once.
What's the common mistake here? When do people mix them up?
Often, beginners try to use SOQL to do a broad search. Like, if you want to find the word Acme anywhere it appears in leads, contacts, and accounts fields, trying to do that with SOQL gets really messy and inefficient. SOSL is built precisely for that kind of multi-object text search. Strategic choice is key.
Okay. SOQL for specific object queries. SOSL for broad, multi-object text searching. Got it. And the last piece of the intermediate stage seems to be navigation. Getting users around.
Yeah, using the navigation mixin. Your LWC doesn't live in a vacuum, right? If you build a component that displays a list of opportunities, you need a way for the user to click on one and actually go to that opportunity record page. The navigation mixin provides standard methods to navigate to records, object pages, list views, even external URLs, all seamlessly within the Salesforce UI. It connects your custom component into the standard user flow.
Okay, so intermediate is communication, data via Apex, and knowing SOQL SOSL, and navigation. That feels like a solid level of competence.
Yeah.
Now we hit segment 3, advanced altitude. This sounds like where we go from functional to truly professional.
Exactly. This is about building robust, reliable, secure, and performant applications. It's moving beyond just making it work.
And the first topic is one close to my heart, testing. Absolutely mandatory for professional code.
Couldn't agree more. This is often what separates, let's say, a hobbyist coder from a professional developer. The syllabus rightly highlights JUST. That's the JavaScript testing framework Salesforce provides specifically for testing LWCs locally.
Unit testing, right? Testing the component in isolation.
Precisely. And the core skill here, beyond just writing a test assertion, is learning how to mock dependencies.
Mocking, explain that.
Okay, so when you test your LWC with JUST, you're running it on your local machine, completely disconnected from any live Salesforce org. It can't call real Apex methods. It can't fetch real data.
Right.
So you have to mock those things. You create fake controlled versions of the data or the functions that your component depends on. This ensures your test is only testing the logic inside your LWC itself.
So if the test fails, you know it's your component's fault, not because the network was down or someone changed the data in Salesforce.
Exactly. It isolates the unit under test. This makes your test reliable and, crucially, makes refactoring your code later much, much safer because you have tests to prove you didn't break anything.
That makes so much sense. Okay, after testing comes performance optimization. Making sure those LWCs are fast and don't drag down the user experience.
Yeah, we touched on cacheable, true, which is fundamental, but advanced techniques involve things like lazy loading.
Lazy loading.
Yeah, basically don't load or render parts of your component or the data they need until they're actually visible or required by the user. If you have a complex component with multiple tabs, maybe only load the data for the active tab. Don't fetch everything up front if you don't need it yet.
Smart. Less work initially.
Right. And also being really mindful of minimizing direct DOM manipulations. The LWC framework handles a lot of this, but doing unnecessary updates to the page structure can be a real performance killer.
Got it. That's a huge one. Security best practices. When you're writing Apex in JavaScript that handles data, this is critical.
Absolutely paramount. An advanced developer must ensure their Apex code respects Salesforce's built-in security model. That means checking for FLS field-level security and C-argued permissions. Create, read, update, delete.
What happens if you ignore FLS in your Apex? That sounds bad.
It is bad. The immediate risk is data leakage. Your LWC, via its Apex controller, could accidentally display fields or even entire records to users who absolutely should not have permission to see them, completely bypassing the standard Salesforce security settings. Big problem.
Yikes. Okay. So always check permissions in Apex. What about security on the LWC side itself? The syllabus mentions XSS.
Cross-site scripting, yeah. Because LWC renders in the browser using JavaScript, you have to be careful with any data that comes from users or external systems. If you just blindly take some input and stick it into your component's HTML, a malicious user could potentially inject harmful script code. That script might then run in the browser of other users looking at your component, potentially stealing their data or performing actions on their behalf.
Okay, so sanitizing inputs is key.
It is. The LWC framework has built-in protections, which helps a lot, but you still need to understand the risks and handle dynamic or user-provided content securely.
Right. Security is everyone's job. Okay, finally, in the advanced section. Deployment strategies. Getting your awesome, tested, secure, performant code from your sandbox into the real world, production.
Yep. And moving beyond just basic manual deployment, while the Salesforce CLI and the deployment features in VS Code are essential tools you use daily,
Yeah.
the advanced stage really pushes towards leveraging CI/CD pipelines, continuous integration, and continuous delivery.
Okay, CI/CD. Break that down simply. What does that mean for an LWC developer in practice?
It means automation, primarily. Instead of manually running tests, manually packaging code, manually deploying, you set up automated processes. Typically, when a developer checks their code into version control, like Git, automated jobs kick off. They might automatically run all the just tests, maybe run some code analysis tools, package the code and deploy it to a testing environment, like a staging sandbox. If everything passes, maybe it even automates the deployment to production or prepares it for a one-click deployment.
So it makes the whole process faster, more reliable, less prone to, oops, I forgot that step, human errors.
Exactly. It's the professional standard for managing software releases reliably and frequently.
Okay, wow. Beginner, intermediate, advanced. That covers a lot of ground. And it all seems to lead to segment 4, the capstone project. This sounds like the final exam.
It really is. It's designed to make you pull everything together into a working mini-app. It's the ultimate test of proficiency described in the syllabus.
So what does this mini app need to do?
Well, it has to fetch and display data using Apex, SQL, and demonstrate, when to use SOSL. It needs full CRU, letting users create and edit records.
Okay, data handling covered. What about the component interaction?
Crucially, yes. It must use all 3 communication methods effectively. Properties for parent to child, events for child to parent, and the pub submodel for unrelated components. You have to show you understand which pattern fits which scenario.
Right, plus navigation integration, presumably.
Yep, using the navigation mixin. And of course, it needs to include comprehensive unit tests written with just proving your code is reliable.
That covers everything we talked about. Is there anything else?
The syllabus adds kind of stretch goal, an aspirational element, potentially integrating with an external API, maybe pulling in weather data based on an account's location or something similar.
Connecting Salesforce to the outside world.
Exactly. That demonstrates a really sophisticated level of application architecture. It shows you can make Salesforce talk to other systems.
Okay, so let's wrap this up. We've walked through this expert-validated syllabus, beginner, intermediate, advanced, capstone. What does this all mean for you, the listener, trying to level up your LWC skills?
I think it means you have clarity. You've got a precise, step-by-step path laid out by someone deeply experienced. It helps ensure you're not wasting time on maybe outdated techniques or irrelevant topics. You can progress logically.
From the absolute basics, right through to building complex, secure, and performant LWC applications. A clear roadmap to expertise.
Precisely. And since that capstone project, the ultimate goal here is about building that integrated mini-app. It brings up a final thought, a challenge maybe.
Go on.
If the goal is to synthesize all these skills, Apex, the 3 communication methods, testing, security into one project, what specific real-world Salesforce problem, maybe something you've encountered at work, big or small, what problem would you choose to solve first to really prove to yourself and maybe others that you've achieved LWC expertise?
That's a great question. What's your personal capstone going to be?
Use that as your focus point as you work through these stages.
Excellent food for thought. And that wraps up our deep dive into the LWC Expert Syllabus. Until next time, keep digging.